Students, this question was asked in the year 1986. If the dimensions of length are expressed as g to the power x, c to the power y, s to the power z, where g is universal gravitational constant, c is velocity of light, and h is Planck's constant, then x is half, y is half, is the option A. Option B given, x is half, z is half. Option C is y is half, z is 3/2. Option D is y is equal to minus 3/2 and z is equal to half. Okay, student. So we have to find out the values of x, y, and z to find out which of the four options are correct. Okay, student. Then we have to first write the dimensions of length L is equal to given g to the power x, c to the power y, and s to the power z, where g is the universal gravitational constant, c is the velocity of light, and s is the Planck's constant. First, let us find out the dimensions of each of them, that of the gravitational constant, that of the velocity of light, and that of Planck's constant. Okay, student? We have studied Newton's universal law of gravitation. Okay, student? What does this law say? If there are two masses here having two bodies having masses m1 and m2 separated at a distance r from each other, students, the force of attraction, gravitational force of attraction between the two bodies will be equal to directly proportional to the product of the masses and inversely proportional to the square of the distance between them, or the attractive gravitational force with which each body will attract each other will be equal to g m1 m2 by r square, where g is the proportionally constant, and this proportionally constant is called Newton's universal gravitational constant, student. Okay, then from this equation we can find the value of g, that is g is equal to, we can write g is equal to f r square by m1 m2, or the dimensions of g will be dimensions of a into dimensions of s square divided by dimensions of m1 and m2. What is the dimensional formula for force, student? That is mlt minus 2, that of r is L, this is length, and m1 and m2 means m into n. Okay, student? This m cancels out, and this becomes m to the power minus 1, L3 and t minus 2. We will write it here. This is m minus 1, L3 and t minus 2. Okay, students? We got the formula for the universal gravitational constant capital G from Newton's universal law of gravitation. Then we know Max Planck's theory of quantum radiation, student. Every electromagnetic radiation is quantized, and what is its energy? Energy of a photon is directly proportional to the frequency of the photon, and given by E is equal to h nu, where h is the Planck's constant. From this relationship between energy and frequency of a radiation, we can find out the formula for Planck's constant h is equal to E by nu. Okay, students, where E stands for energy, nu for frequency, and so the dimensions of h will be dimensions of E upon dimensions of nu. What is the dimensions of energy, student? We know all forms of energy have dimensions ml2 t minus 2, and nu, what is nu? Frequency is the number of oscillations per second, that is 1 by time period or 1 by t. So this possesses dimensions t to the power minus 1. So this becomes, student, ml2 t minus 1. We will write it here, the value of the dimensional formula for ml2 t minus 1. Okay, student? And what is c? C is the velocity of light. It is one velocity. So what is the dimension of velocity? What is velocity? Velocity is the time rate of change of displacement. Okay, student? How much a body gets displaced during a particular time, that is its velocity. And so this is L by t, or L t minus 1 will be the dimensions. So we got the dimensions of the three physical quantities, and now we will put these values in this equation. Okay, student? This will be equal to, what is g? G is m minus 1, L3 t minus 2 to the power x. Okay, students? Then we will write lt to the power minus 1 for c. C is having y exponent, and that of h is ml2 t minus 1 to the power z. Let us expand m to the power minus x into L to the power 3x into t to the power minus 2x into L to the power y into t to the power minus y into m to the power z into L to the power 2z into t to the power minus z. Okay, student? Then we can write this as m to the power minus x. Where is m? Here m. Okay. And the exponent is z, so we can write m to the power minus x plus z. Okay, student? Here is 1m, here is 1m. And L to the power, here 3x, we write it 3x, L to the power, here y, we write plus y, L to the power, here 2z, we write plus 2z. Okay, student? And t to the power, t is having exponent here minus 2x, we write it here minus 2x, and t to the power minus y here, and t to the power minus z here. Okay, student? And this is equal to what? Dimensions of length. So, what is dimensions of length, student? That is L, or L can be written as m to the power 0, L to the power 1, t to the power 0. Okay, student? Then, from the principle of homogeneity of the dimensions, we know the dimensions or exponents of the three physical quantity, mass, length and time, will have the same exponent or the same dimensions in the left hand side of an equation to the same as the right hand side of the equation. Okay, student? Then what is the exponent of mass here? It is 0. What is the exponent of mass here? That is minus x plus z. So minus x plus z is equal to 0. And what is the exponent of L here? That is 3x plus y plus 2z. And what is the exponent of length here? That is 1. So we will write 3x plus y plus 2z is equal to 1. Okay, student? And this is minus 2x minus y minus z is the exponent of time. The exponent of time here is 0. So we write minus 2x minus y minus z is equal to what? 0. The exponent of time is 0 here. So let us add this equation. 3x minus 2x means x, student, y cancel, and this is 2z minus z means x plus z is equal to 1. We got x plus z is equal to 1, so we can write it here x plus z is equal to 1 and add these two equations so that 2z becomes 1 or z becomes, student, half. Then what is x? X plus z is equal to 1, so x is 1 minus z or 1 minus half is equal to half. Okay, student? This is the value of x is half, z is half. What is y? You can find out y here. Y is 1 minus 3x minus 2z. Then that is 1 minus 3 into half minus 2 into half, student. So this becomes, this 2 cancels, and this becomes 1 minus 3 by 2 minus 1, that is 1 cancels, and this is minus 3 by 2. So value of y is minus 3 by 2, that of z is half, x is half. So student, let us see, x is half, y is half, this is correct. X is half, z is half. Sorry, x is half and z is half, not y. X is half and z is half, this is correct. Y is minus 3 by 2, so this is not correct. And y is half, z is 3 by 2, this is also not correct. Y is minus 3 by 2, z is half, this is also correct. So students, B and D options are correct in this question.